First of all, thank you so much, like Vit. And by the way, his short name is Vit. And Vit in French, it means rapid or quick. But doesn't mean that he add more money, like 2 million, 500 million, something like this. But anyway, thank you for him, like for hosting. Thanks for you for your coming and attending my presentation. Nice city, nice place, nice time. Today, like we are gonna to talk about one subject, one of the main field important in artificial intelligence. As we all have a background in machine learning, computer vision, we know the promise of machine learning. It means that based on the fact that every day we have data generating coming from videos, images, sensors, and this data doesn't look like gonna to slow down anytime soon. So machine learning promise, you know this fact that promise us that to derive the meaning from all of these data. So, and here we are gonna to talk about intelligent vision system, and the special case is anomaly detection in video. So, can machine learning help us to find the anomaly detection, to detect and localize the anomalies in the videos? So this is my name. My name is Mazen Hittawe, and actually I'm working a teaching position in UTT, Université de Technologie de Troyes in France, and research in KAUST. KAUST, as he said, is just a city for researcher, and it's bringing the researcher over all the world. And this city has only post graduate, just master, PhD, and research scientist and postdoc. And it's really one of the top 50 university. This is a classification of 2017. So first of all, we would like to define anomaly. What's anomaly? When you say that I'm working anomaly detections. So the answer, no, I think anyone will say, what's anomaly? And no one can answer what's this exactly. And even us, which work in the same field, I mean, we cannot define the anomaly. Because anomaly is subjective and depends on the context. What I'm saying that if I have videos belong to the train station, like surveillance for the train station, and there is something abnormal in this video, it's not the same if we have video in the airport and doing surveillance on the airport. The anomaly there is not the same as an anomaly in the train station or in the city center. So we are trying is, I select this subject because we work in many projects of research. I select this subject because this conference has people belong to research background and people belong to the engineering background. Some people don't care about research. They need to, just interesting in engineering. And some people, no, they would like to work only on research. So I select this subject because it's interesting for both, for the engineering background and for research background. So I will talk in 2 points of views, research and engineering, for startup, because we have some 3 to 4 startups running right now. I cannot share more detailed information, I'm sorry from the beginning, for the details. So, but I will give the ideas, and I will try to give really the important notes about this field. So, as I said, because of the data coming from the videos, let's say sensors, cameras, or whatever, I mean drones. So, monitoring this data is so difficult because the operators, the guy who is sit beside the screens, I mean, how he can control the movement in city center or movement in let's say in the airport or something like this. So we have anomaly detection. We have let's say tracking, drone control, and person identification. This is the main topics we are working with for this field. So, I don't know, something here happened. Why is that not written something here? Anyway, This is like for re-identification and tracking, we need to start from face recognition. Then we need to do identification person, and the last step will be tracking for this person in the videos. So which person would like to select will be our target, and we have also limited access, limited like, let's say, resources, because we have a large number of targets. Here, the objective is, for anomaly detection, is to detect and localize, not only detection in each frame in the videos, that also we would like to localize exactly where's the abnormal event inside these videos. And then we would like not only like to localize in each frame, we would like also to track over the time in all the videos. So the main challenge, let's talk about, like, if you do research, I mean, in point of view, like some researcher, like they would like to come back over all the related work and see what's going on for this field. The main difficulties in this field, like for anomaly detection, is the first main challenge, as I said, there is no like specific definition for anomalies. This is really the most difficult thing, because it's subjective and depends on the context, where I am now. The second thing is, we have the abnormal event is not a lot. It's like so rare, I mean, it comes in the video. Because like if we say our videos has 90% of normal life and have 10% sometimes of abnormal events. Because of rarity, I mean, we don't be able to create rich database for abnormal events. And the third difficulty is, if you would like about autonomous like intelligent system, we have really to create robust algorithm and artificial intelligence which can able to do this task. Here, like for example, like we'll talk about this, some examples like I see here, like if there is any aggression in the video, or if there is like one video that one person like falling on the ground, you have to detect and localize. And like for example, like we have two types of, like let's say videos, like we have low density in the videos, or like we have also dense density in the video. Based on the fact that we cannot define the database of abnormal events, and we would like to use like the machine learning in order to detect this abnormal event, so directly we think about unsupervised anomaly detection system. Because like, as I said, we don't have these cases in our database, and abnormal events is changing. And like new cases coming daily, and we cannot like update the database every time. So we have the videos here, the frames, and all the people, as you see today, that they said deep learning. In point of my view, I mean, I say like, just like my point of view, I mean, when the people like use deep learning, yes, it's true. They have found robust solution. But is it true like in terms of research? I mean, we do something? I don't agree that. Even if we, like some of my PhD students, use deep learning to find solution, like say, I do a new research and I found robust result. I say yes, but it's not real research. What you do in terms of deep learning exactly? You have two options only. The first option, you take the neural network, which you will see right now, later. You add many layers, you do like fine tuning, you find result. Or some people have like, let's say, capabilities, I mean, in US, or in some rich countries, they have like supercomputers, and they create a new network, new sophisticated networks, and they train this network over millions of the images or data, whatever, and they found a new network, and they say this is like new research. This is like, in my point of view, that looks like more engineering. That's why I select this subject also. It will be also be interested for the engineering area. So the objective, like let's say, is to find like this sphere, because this sphere it means like, can we able to find the border of normal events. And if we cross these borders, I mean, we found something is called abnormal events. And maybe sometimes we'll find something on the border, we don't know. It's like suspected events. Maybe normal, maybe abnormal event. So we can, like, I have some videos about our results. I mean, here we have, as we see, like, videos is not clear at all, like small objects, sometimes dense. And the objective not only work on specific video or specific videos, let's say, is like to find a solution, intelligent system look to catch the anomaly in any videos. And here is like some of the results that how to localize, not only detect the abnormal events over all the video. So one of the research, like I think, is like online, abnormal event detection using CNN, convolutional neural networks, and one SVM classifier. So, in the research, since 1995 till 2010, there is like two interesting papers, like what we found, that they said that in the first study that, like, operators, the guy who was like, instead of the screen control the events and the videos, like 60% he missed of the target if he just watched 9 screens in the same time. That means he is losing really 60%. Another study, they found that after 20 minutes of focusing also, they lost 95% of all activities, just after 20 minutes of focusing. So, and for the startup way right now, not only research, can we find like intelligent vision system can really do this without any operator? And because, like, let's say we have here like many cameras in the same time sometimes, and it gives us lack of efficiency for the operator. So in this intelligent vision system, there is 3 main steps we have to achieve. First of all, image acquisition to take the data, and the second one, do processing, and the decision also we'd like to be automatically. Not put someone, I mean, to check even our results or something like this. We need the decision to be automatically and generate some alarms, like due to, like, according to the anomalies. So, as everyone would like to present, he will talk about the subject, about related work, about the proposed method, experimental result, and the conclusion. So I don't know what is happening. Yes. So, here's some example, like what we are, like some videos we are applying. We don't work in specific videos. We try, this is for many type of videos. For the aggression, like if anyone like has aggression with someone in the videos, really are we able like to detect it also and localize it? And for fallen person, and also like the main important videos, which all of these data sets are online. This is really many advantages. Like we don't work in specific data set and say like this is our solution, one of the best. No, this is all of these databases are really online databases. And here, like, can we find something like, as you see, like the definition of anomaly for first video is not the same the definition of anomalies in the last video. For example, the anomaly in the last video is non-pedestrian, let's say, presence in pedestrian area. Can, like, if we find something like this, we'll say that this is anomaly. For example, the airport, if someone keep his luggage and he left, this one is considered as anomaly. It's not the case in any place. So, many articles, like many like state-of-the-art work on this. One of this like state-of-the-art working in the analyzing the trajectories of the people, of the objects in the videos. And from these trajectories, like they generated from the videos, they try to investigate if there is abnormal events in videos or not. Some other studies, like, let's say, working in low level of features. Like, let's say, if we take image by image, you know this, for example, and if there is a changing in the orientation of the image, so we use, for example, hog features, or if there is a changing in texture, we use like LBP, local binary pattern. So some people like try to extract low-level features from the videos and try to study the behavior of these features. Here, some results of this abnormal. You see, like it's not like giving us a good result sometimes because like mixing. Another study like also starting to work on deep learning, and from this one, we go ahead for our research and for like our startup to use robust solution based on deep learning. So this is our framework. This is like, let's say, our basic framework, because now we have more sophisticated frameworks, more complex frameworks right now. So the idea is, give us the video, so easy, so simple. We will extract the features or characteristics from this video. So we will turn the video as characteristics. And then we will try from these characteristics or features we have to learn something or to find distribution of this feature. And then, can we find this sphere? This is the main objective, like to separate between normal and abnormal events. So, also, it's like right now, like most of the people like do the same. I mean, no one will take a neural network, let's say, neural deep network, I mean, and try to train it from scratch. And most of the people, they take a pre-trained network because most of the weight will be like conversions. I mean, the error will be minimized already. We talk like a pre-trained network. We change a little bit in the structure, and we do something is called fine-tuning. And this is the structure, and this is like, as I said, the basic solution. What we build like is like version of AlexNet. This work was developed using Coffee library, and this like already trained with 1,000 categories, and almost about 3.5 million images, already pre-trained this by the other researcher. So for feature extraction is the first step of this flowchart is to generate the matrix F. I mean, most of you, I think, know this scenario. I mean, just like to take the input frames, like, or videos, and try for example, 3 by 3 pixel or 7 by 7 pixel, try to do convolution and pooling in order to find F1. F1 is vector, like 256 multiply 529, and represent the first batch in that frame. So based on this idea that we know that each vector corresponding to which batch in the frames. That really will be helpful for us. So we do like many experimentation to take the output of first convolution layer. We take the output of second, of third, because it has this structure, 5 layers of convolution and 3 fully connected layers. So after many experimentation, we found that let's take the convolution. Best results were obtained like for first layer of convolution pooling and the second layer of convolution. But we take some images or some images from our videos for normal class. We don't do any training for abnormal events, and we do something is called fine-tuning. That means we give these images in the training stage to this network in order to do this fine-tuning. And finally, we found the output feature vectors here as our characteristics. Then, here, like, we try to take these features and train a classifier. Actually, like, for our startup, we don't use the solution. It was like just for research point, just to show the results. So we try one classifier. One class is VM classifier. We use, and the best results were obtained for the polynomial kernel of degree 2. And This is like, you know, it's like known for everyone for the one classes VM in order to find these things. Like the normal class in the green and the abnormal event sometimes will be like the red points. So localization, as I said, after we able for the classifier will detect in each frame there is anomaly or not, we would like also to know exactly where is this abnormal event. So localization as means you have to come back using for these vectors. We come back exactly for each vector to the patch which we have already started. This is the algorithms also. It's already developed, I mean, in terms of engineering area, I mean, we take all the frames in the videos and we extract the features, and our matrix of results will be of links 529 multiplied to 256. This is our F, and then we give it to any classifier. Actually, if after we take this feature or characteristics, we try to project this data, but it like cannot be imagined because it has not 2D dimension, it's 256 dimension. So, and we try to do like find the distribution, I mean. In sample video, we find that it looks like Gaussian distribution. And we are able like also for not only to train classifier, just to find the best distribution, I mean, to find Gaussian like and then calculate for any new features, the distance between this vector and the Gaussian distribution. If this distance really more than one threshold, then we say this batch is really abnormal. As here, like we say, this is also after we take the model, we have our model, and we have our vector test, and we try to find the score. This score will be compared with one threshold is given by experimentation in order to say this normal or abnormal event. So this is like already, I have some videos, I didn't know he can like show us for the abnormal events. In order to validate this work, we use like something is called estimated error rate.
Do you want to show videos now or not?
Later, no problem.
Later? Just call me and
okay.
we will show. Okay.
So this is like our results for this research. We found the error is 25%. That means we are able to, our system to detect up to 75, which is not enough like if we'd like to talk about startup or about engineering area. So right now in our work, real work in the startup, we have the error is 8%. I mean, we improve this error from 25 to till 9%. This is the error. And this is like the experimentations for many folders of the, in each data set, there's many folders. I forgot the percentage, maybe, yes, in some here field. But let me talk about the new solution we generated and to improve this results from 25 of error till 9%. So we try to use something is called, I don't know, 3D neural network. I mean, in the video, there is motion in the video. And to take in consideration the movement in the video, so we talk not only 3x3 moving, let's say, batch on all the video, but also we take in the same time this one for many frames in the same time. So we take that in depth in order to take in consideration the movement in the video. That's what we use like 3D neural network. And with this one, also, we use it also like the approach of a graph in order to change the visuals as a graph, and then we do some matching between the normal and abnormal events. So this is like here, as we see that in the results of no detection of abnormal till they have really real touch between them of aggression, then we are able to detect this event. So that's really the conclusion. I mean, for this, I mean, is like comparing to the state of the art, one of the best because like we add just a layer and we do fine tuning for the neural network. And this is like what we use right now, 3D CNN, in order to find better solution. And the best results were obtained for ResNet network. Thank you. If you have one question.
Mazen, do you want to show videos or no?
Yes, why not?
Yeah, let's see some videos, and you can, or we can go with questions. What up to?
Go ahead.
Yeah. Okay, we can. Yeah.
Hi, thanks for the great talk. One question: how do you deal with seasonal changes? Like, what if employees like to fight in autumn, but they do not actually fight in summer?
Exactly. Yeah, I mean, like, this one is very important because not only the season changes, I mean, even sometimes, like, when we're talking about startup, not like the same exactly like research. Like research, we take only specific database.
Yeah, sure.
I mean, the position of camera is fixed. And as you said, the conditional, like the condition, weather condition is the same. And they try to do the same results in order to improve about the others. But in startup, as you said, we have to take care about the change of the position of the camera. We have to take care about if have video outdoor, not the same like indoor. Maybe it will be sunny, maybe it will be cloudy. Yeah, on all of this stuff really needs like to improve this point using fine tuning. I mean,
You fine tune in time, yes?
yeah, yes, we give like more examples of the videos like related to these changes. Like if we change the position of camera, what's going on? If we change the like summer, not winter, not autumn, all of this. We improve these results in our startup using this fine tuning. Yeah.
Thank you, and I have not important but very interesting practical question.
Yes.
Why did you choose polynomial kernel? For my experience, the linear kernel sometimes does almost the same job as the polynomial, and more than that, it's very difficult to find the exact value of degree.
Yes.
The required polynomial.
Yes.
So it requires a lot of experimental or
That's what we
something
did.
like
That's
that.
what we did here. That's really a good question. Thank you for this question. Why polynomial give us the good question? Because really that the distribution of the features when we do projection is really like with linear is impossible. We try a lot, and as we had a lot of difficulties to detect the degree of polynomial. Exactly. We apply many optimization techniques in order really to find the best value of the degree on polynomial. Yes.
Next question, you.
First of all, thanks for your great speech. I've got a question. You've mentioned the Gaussian distribution to actually determine the abnormality of a specific event. How did you came up with the Gaussian distribution? Is it the theoretical or some empirical like guess, or have you ever tried some kind of more complex distributions like Johnson's or Pearson's models, so on?
Yeah, I mean, go ahead.
I just want to add.
First of all, one of the simplest distribution for the data is considered as a Gaussian classifier. The second thing is, imagine that we have distribution like 2D, okay, of the characteristics, I mean. If we are able to find this distribution of Gaussian who contain or cover like all these characteristics, and also we are able to find the distance between any new like batch, like test frame in the image, and this Gaussian classifier. We think about this, but in sophisticated videos, it's not working. Exactly what you said. The Gaussian is not working at all, because when you apply Gaussian classifier for distribution, you find flow Gaussian. And in this case, if you have a flow Gaussian with big value of sigma or mu or something like that, it's impossible to. You will find the border is like big borders. I mean, contains everything. So I mean, any new events will be considered as normal. We will not be able to catch any abnormal events. So exactly, but for these cases right now, why we have this high, like let's say 25% of this error because of this, I think. Because whenever we don't do tests for only one case of, for example, let's say videos coming from pedestrian, non-pedestrian. We do that for many type of videos, and we apply the same techniques for all this type of videos in fine-tuning and all the changes. And then we found this one. In other, like let's say in our advanced, what we achieved till now, 93% of accuracy, like we have like 8 to 7% of error, EER. Yeah, we changed the distribution of the data. That's right. Thanks.
Next question. Okay, for you.
Okay, the question
Yes.
about your current model with ResNet and 3D convolutional
Yes.
neural network. So the first question is, how fast is it? So in terms of how many video streams can you handle on one GPU, for example?
Actually, like for this real time is considered as important factor. I mean, for the startup. Yeah, that's true. We have, yeah, I mean, we can able to really, like, you know, like this, all of this stuff will be offline. Whenever we have our model, will be like everything online for the testing. Actually, we have, like, you know, if you go for the details, I mean, I don't know exact number of the seconds it takes. It depends like the volume, because we have generate the results and the tables based on that like size of the videos of testing and how much time it takes. And we write exactly our CPU and GPU capabilities, I mean. But I don't exactly remember the exact chip for this. Because this one exactly not for the startup, as I said.
And if you have the pre-trained neural network to extract features, it will not work in some other settings. So how do you deal with it?
Other settings, what you mean exactly?
I mean, if you had trained the neural network for airports, it will not work for...
Yeah, for our startup, there's two parts, yes. I mean, the first one is, which already done, I mean, to find something is called intelligent camera, like it's already done like years ago, I mean. We have microcontroller in this camera, and we put the algorithm, everything in this microcontroller, and the camera can find and do the acquisition and the detection and localization at the same time. This is what we said. And your other part of the question, what was? How we, I mean, yes, if we change the setup, you mean?
No, I mean, do you have like one model, general purpose, to extract features in all settings? Or you train it on your data specifically to location?
No. Because like if you are like, no, we have global things till now. What we achieve like 93% like accuracy is like globally, not specific based on the airport or city center or no. It's like globally.
And on what kind of data it was trained then?
You postpone? You mean like fine tuning?
You mean I mean this general purpose one?
Yes. We take the pre-trained model, ResNet, okay, and we do
on ImageNet and
yes,
okay,
exactly.
Thank you.
Next question.
There.
Okay. Yes.
Okay. Thank you for your speech. My question is, you were talking about that we have unsupervised learning, and you are working with all types of abnormal events, yes? But it seems to me that why shouldn't we use more like accurate models prepared on specific, case? Like if you know there is one startup and R&D in Ukraine, Ring Doorbell, yes? And they have abnormal events like people are doing aggression near their house, yes? And why should we choose your solution, which is, I know percents, but more like accurate. And
if I understand really from your question, why you use global solution if you are able to specify
yes,
the
because
cases?
usually
This is like your question, right?
Yes.
The answer will be like so simple. I mean, no one prefers the specific case. I mean, suppose you are a startup, and today the airport come to have a contract with you, and then you will do like specific solution for them, and then you will do almost the same again for the fine tuning for the city center or something like that. But if you are able to find really global solution, can deal with all of these cases with acceptable error, why not? This is my answer. And think about it.
Hi, thanks for question. You mentioned that your improvement have got through using 3D convolutions
Yes.
to represent this
Yes.
important information. How could you explain your motivation behind choosing this particular architecture? Because I know in events detection there are also other approaches like two-stream temporal segment networks and you know, some other newest findings in that. So
Yeah, I mean, like, why select this?
yes,
specific-
why you could also have chosen like CNN plus LSTM to represent that like features known on top of CNNs and then put them in LSTM, but you chosen 3D. So
Why
do you
is-
think it's worth to develop more that particular part or?
Yes. That's really also a good question. Thank you so much. Why we select this really specific network? Because of two things. The first thing that when we are presenting here the 2D like representation on the videos, not 3D, I mean, we don't take like in consideration the movement in the video. That's why we take 10 frames in the same input. I mean, when I'm taking batch size moving all of the frame, I'm taking also this batch size in the 10 frame at the same time to take like in depth the motion in the videos. The second reason why we use this network because there is like one interesting research done by University of George Washington. I mean, and this they do really nice comparison between all the networks up to 2017, something like that, and the best results were obtained for this network, ResNet. So we selected this network, and at the same time we try many other networks. I mean, and really the best results were obtained for this network. I mean, in our case. I mean, like for these two reasons, we go ahead with this solution.
Hello, thank you for your talk. I have one question. If you have a global network that's detecting anomalies in multiple scenes, how do we distinguish between what is an anomaly? For example, on the street, if people are fighting, then that's an anomaly. But if you use the same network in a fight club, then it might be.
Sure. I think
okay.
one of your colleagues here asked almost the same question. He's this guy, I think. How we like distinguish between these two cases is the solution we use fine-tuning. So we give the fine-tuning for our networks for many cases. But we don't do training from scratch. We use, as I said, the pre-trained model, and we do fine-tuning for our cases of normal life without any abnormality. We give this example. I mean, it's so quick. For 200, 300 images, we are able to do fine-tuning.
Thank you. I have a question. What is the limits of this approach? In what cases your model will not work as good?
Sure.
As example, I know one of requests, like say from customers, is to detect an anomaly in boxes that are damaged, just the paper boxes on the conveyor. Will your model work? In what cases it will not work? Or it will work in any cases?
That's really also a great question. I mean, we don't say, and we are not able to say that our solution is one of the best. I mean, I agree with you. If you are doing research papers, you have to do marketing a lot, and you say, to best of our knowledge, you are the best in the world. I'm not saying that at all. We have really a lot of, let's say, limitation of our work, a lot of like difficulties we still like faces till now. I mean, in this field, like after really like big experience on this field, I mean, I could say it's impossible to minimize error like till 99% till now to find really intelligent vision system achieve for you of accuracy 99%, because like even for the really like let's say. For the human being, it's so difficult sometimes to differentiate between normal and abnormal events. And abnormal events, like every day, like it's changing, like time to time and day to day. I mean, one of these difficulties, other difficulties, what I mentioned to your friend, that when any paper read it like to tracking, for example, they say that we have tried this for this data set, 1, 2, 3, but no one, for example, care if I change, as I said, the position of camera, not in the same place, or like the weather condition, what happening going. No one talk about, or really like so limited number of researchers like discuss these areas. Yeah, we have big limitations, like not like we have limitation on this area, that's sure. We try really to avoid it.
Okay. Thanks for presentation. I have a question. According to your evaluation, you told that your system get 8% error.
Yes.
So maybe I missed this, but does it mean that each 8 seconds I say 100 seconds, your system will say that some anomaly happens?
Not at all. No, not at all. We don't calculate this one based on the time right now. For in research, when we said that error rate estimation or error estimation rate (EER), like we calculate this one both based on the false positive, false negative values in your detection. We don't care about the seconds at all. I mean, when we have 8%, I mean, we calculated this, I mean, based how many false positive have, how many false negative I have for each videos, I mean. Some videos like does not have the same links, I mean. It's like different.
So it's for some like among all video samples, 8% is classified
This is like
incorrectly.
8%, like the average EER for over all the data set which we do the experimentation. And in each data set, as I said, there is videos, and each video is different as length from the others.
Okay, thanks.
Welcome.
Yeah, Mazen, I forgot to mention what we have a company in Ukraine,
yes,
which acquired by Amazon for like $1 billion, and like R&D in your area mostly based in Ukraine.
Is here in Odessa or Kyiv?
No. It's, yeah, in Kyiv. Yeah,
that's really interesting.
And some of the people who are asking some interesting questions actually from this company.
Oh,
So
okay. Welcome. Welcome.
Hey.
So you have to pay for
So maybe a question about, I guess, more of an industrial use case. So
Yes.
as you mentioned, I guess purely computer vision systems can get a bit high on the error, and the problem with humans is that after 30 minutes they get bored.
Yes.
Basically, have you considered some sort of human-machine collaboration, where basically a machine will say like something is suspicious, and then there will be a human who will verify it or cancel the request?
You mean like why we don't ask
Why
the
don't you
human
use-
to interact? you mean?
Basically, use a human-machine collaboration versus purely machine.
We don't think so, because as I said, that the objective to find something isolated to the human actions. We don't need any, like the intelligent camera, I mean, it's not allowed like for this solution to find anything from the human being. But like could be interesting, like, I mean, if we can integrate the humans, I mean, inside the solution. But the objective really to find solution like without any human interaction.
More questions?
Yes.
You okay to take more?
Yes, fine,
Okay,
fine,
okay,
fine.
okay.
Thank you for your presentation. The first question is that you said that you use ResNet, right?
ResNet,
as a
yes.
pre-trained network, and
Yes.
then you say that you use 3D convolutions. So are those 3D convolutions go into the kind of the parts of the network that you fine-tune? So how do you kind of combine the 3D convolutions that are absent from the ResNet, and there is no way to train them on ImageNet, right?
Sorry?
You cannot train 3D convolutions on
Yes.
ImageNet because there are no kind of videos there, it's only images.
That's true.
Okay, so 3D convolutions go to the parts of the network
Yes.
that you fine-tune
Yes.
later, right?
Yes.
And like, how do you combine ResNet and 3D convolutions? Could you please?
Yes, because this one, like you say about fine-tuning, you mean? I mean, how we do fine-tuning for this? Because the input will be images, not videos. That's what. And also, we give like input as images, not videos, even for the fine-tuning for the 3D network.
So your input is are always images?
Yes, because like will be like frames. I mean, in the videos.
Okay, and then for the fine-tuning in your dataset, you have labels or is it in some unsupervised learning?
No, it's line supervised without any label. But what we know exactly that this data coming for fine tuning, it doesn't have any abnormal events. This is the main condition because we don't know exactly the abnormal events, and we give the data as normal events.
Okay, yeah. Then my question is, if you have no labels in your data set and you do it in unsupervised way, then basically, what ground truth do you give to the network for fine tuning?
Just like some images of our cases, like to be like global solution.
Yeah, but the network needs the ground truth. Is it the same image that you give to the network as an input? Or
yes, the same images.
So you ask the network to restore
exactly to go through all of the structure. I mean, from the beginning till the end, with these images for the fine tuning.
Oh, so it's like variational autoencoder.
Yes.
Okay, thank
I
you.
agree with you.
You mentioned what in Saudi you have a supercomputer.
Yes, sure.
Do you have access to this supercomputer, or?
Sure, it's called this supercomputer is called Shaheen.
Oh my God! Okay.
Yes,
and
yeah, it's really like have big capabilities. I mean, whatever you would like to do, training is so fast. I mean,
and this is, can you use it from this city? Like how? What is the terms of uses of this supercomputer? Like
you use it from the city.
I mean, how you can use it?
Just like you will have access.
So you can just pay, or you need to have some super access?
No, I think, I mean, you are from outside, you would like to use it, it's not allowed. I mean,
Okay.
you have to be local, I mean, inside, working inside, and then you can access. I mean, sure, no one can access, otherwise will be...
Okay. Because maybe we can mine some bitcoins or something. For free. More questions?
There is another one in USA if you want.
Okay.
Try.
It's easy? You think so? It's easy? Okay, I think no more questions. Make applause to Mazen. Thank you very much for your job. Thank you.